Galileo Galilei is often called the father of modern science. His careful eyes and bold mind helped change how people see the sky, the earth, and even themselves. Today we live with satellites, space telescopes, and phones that use precise physics. Long before these tools, there was one man in Italy who asked simple but brave questions. What is really true? How can I measure it? Can I test it again? His name was Galileo, and his life story is full of curiosity, courage, and patient work. In this story, you will hear how Galileo watched a lamp in a church and started to think about time. You will learn how he studied shapes and numbers, how he taught students, and how he made instruments. You will follow him as he points a new telescope to the night sky and sees things that many people had never seen. He found small moons going around Jupiter. He saw dark shapes moving across the bright face of the sun. He watched the moon and found that it was not smooth. These things were simple to look at, but powerful in meaning. They showed that the heavens were not perfect balls of light. They were real places with movement and change. Stay with this story to the end to feel his long struggle and lasting impact. If you enjoy clear and inspiring life stories in simple English, remember to subscribe to this channel now so you do not miss the next story. Early life. Galileo Galilei was born in the city of Pisa in Italy in the year 1564. Pisa had tall stone buildings, narrow streets, church bells, and the famous Leaning Tower. His father, Vincenzo Galilei, was a musician and also cared about new ideas. He did not only play music. He studied how strings on instruments made different sounds. He liked to test things. His mother, Giulia, cared for the home and the children. This home was not rich, but it was alive with thought and sound. From a young age, Galileo heard music, talk, and question after question. It was a house where thinking was normal. As a boy, Galileo sometimes watched oil lamps hanging in churches. One day he noticed a lamp that moved gently back and forth after a small push. The time of each swing seemed almost the same, even when the swings became smaller. Later he would remember this and think about it again. He did not yet build a tool for timing a pulse with a pendulum, but the memory stayed. He also liked to draw. He had a good eye for lines and shapes. Drawing helped him look closely. His father first wanted him to study medicine because doctors could earn more money. So Galileo was sent to learn Latin and Greek and other subjects that would prepare him for higher study. When he was a teenager, the family moved to Florence, a center of art and learning. There the Medici family ruled, and there were libraries, workshops, and places where people met to talk. Galileo saw engineers, painters, clockmakers, and map makers. He began to love mathematics more than anything else. Numbers felt clean and clear to him. He liked that a proof in geometry could show a truth that no person of reason could doubt. Still, his path was not straight. He had to balance his father's hopes, the need for money, and his own desire to study what he loved. Galileo also learned to look at everyday things in a new way. He watched people carry water. He watched children play with balls. He listened to the sound of hammers. All these things could become parts of questions in his mind. Why does something speed up as it falls? Why does a long string sound lower than a short one? He was forming the habit that would guide his life. Observe, ask, test, and observe again. This way of thinking would one day shape modern science. A student years. At age 17, Galileo entered the University of Pisa to study medicine. The path began with lectures in logic and natural philosophy, then more about the human body. He sat in halls where teachers read long texts in Latin. The style was often slow and dry. Galileo's mind, however, was turning toward mathematics. He soon attended lessons in geometry. The clear lines and reason of math drew him away from healing the sick. He learned about Euclid's Elements, an old book of shapes, lines, and proofs that still guided learning. He could see how each idea came from one before it. He felt joy in this step-by-step building of truth. Money problems soon pressed on the family. Galileo did not complete a medical degree. Instead, he left the university without a title. Still, he did not stop learning. He went home and continued to study math on his own. He read ancient works by Archimedes. He copied them. He tried to follow each argument with care. He began to write small notes. He also made friends with other thinkers. Step by step, he became known as a clever young man who could explain difficult ideas in clear words. During these years, he studied the center of weight of objects. He wrote early essays on this. It was not yet a famous work, but it showed his direction. He also gave private lessons to students. Teaching helped him polish his own understanding. When he had to explain, he had to be clear. When a student did not understand, he would try a new way to say the same thing. This practice helped him become a strong communicator of science later in life. In his student years, Galileo also learned to respect the power of instruments. A simple tool could make the senses stronger. A balance could reveal small weight changes. A compass could guide the drawing of a perfect circle. Years later, a telescope would expand the eye. He began to dream of tools, not just as aids to trade or war, but as bridges to truth. A clear tool and a clear method could cut through long words and show nature in action. The world around him was also changing. Trade was opening seas. Sailors crossed oceans. Maps grew richer. New plants, animals, and peoples were described. Old ideas were being questioned. Galileo's mind lived in this air of change. He was not a man locked in the past. He was a young thinker, eager to join a larger human effort to understand the world with fresh eyes. First discoveries. In time, Galileo sought stable work. He gained a position as a teacher of mathematics in Pisa in 1589. The pay was modest. The halls were not always warm. Yet it was a place where he could stand before students and speak about numbers, shapes, and motion. He began to question accepted ideas about falling bodies. Many people still believed ideas from the ancient thinker Aristotle. One common belief was that a heavier object fell faster than a lighter one in direct proportion to its weight. Galileo asked if this was true. He thought about it first in words and logic. If a heavy stone falls faster than a light one, what happens if you tie them together? Do they fall faster or slower? This playful thought showed a problem in the old belief. According to later stories, Galileo dropped two objects from a height, maybe from the Leaning Tower, to show they landed close together. Whether or not this famous scene truly happened in that way, his experiments and careful thought led him to a new idea. In the same medium, and ignoring air, objects fall with near the same acceleration. This was a deep change. It was a move from trusting old words to trusting measured experience. He began to use ramps to slow motion down and measure it with more care. By rolling balls on inclined planes, he could watch how speed changed. He found that distance traveled grew with the square of the time. These ideas were seeds that later thinkers, including Isaac Newton, would grow into a larger theory. Galileo also studied pendulums. He noticed their nearly regular period for small swings. This idea would one day help in making time devices more accurate. He did not yet have all the parts or support to build a great clock, but the concept was there. He was building a picture of motion where time and distance could be linked in a simple pattern. He wrote letters and small papers to spread his findings. Not everyone liked his style. He could be sharp when he criticized old views. Some older scholars felt attacked. Yet his confidence came from his method. He could point to a setup, a measurement, and a result. A student could repeat the steps and see the same thing. This repeatable nature of experiment was part of a new path in natural philosophy. Teaching and experiments. After some years, Galileo moved to the University of Padua in 1592. Padua was under the rule of Venice and enjoyed relative freedom. There he taught geometry, mechanics, and astronomy. His salary improved. He stayed there for many years. These were productive and happy years. He built instruments, wrote texts, and gave lively lectures. Students came not just for formulas, but for a way of thinking. He designed and improved devices for measuring. He worked on a geometric and military compass that could help with aiming guns and solving math problems. This brought him some income through sales and lessons on how to use it. He also studied the strength of materials. How much load can a beam take before it breaks? How does length and thickness change that? These questions were useful for builders and gun makers alike. Galileo's notes began to tie math to the real needs of society. In his home life, he had 3 children with a woman named Marina Gamba, 2 daughters and a son. The daughters later entered a convent. Money remained a concern, and he had to think about dowries and family duties. His letters show care for his daughters, especially the elder one, who took the name Sister Maria Celeste. This human side reminds us that Galileo was not only a sharp mind. He was also a father facing normal worries. In Padua, he continued to refine his studies of motion. He understood that uniform acceleration produced patterns that could be expressed in simple math. He made inclined planes smoother. He listened to rolling sounds to judge steadiness. He used water clocks to measure intervals. These homemade methods were not perfect by modern standards, but they were clever and careful. They allowed him to go beyond vague words and get closer to numerical laws. He also began to think more about the heavens. At that time, many models of the universe were debated. The old Earth-centered model placed Earth at the center, and the sun, moon, planets, and stars moving around it in complex circles. A newer model, first strongly argued by Nicolaus Copernicus, placed the sun near the center with Earth and planets moving around it. Some earlier thinkers had similar ideas, but Copernicus gave a detailed system. Still, many people found the idea hard to accept. It seemed to go against common sense and certain readings of religious texts. Galileo watched the debates and gathered small arguments. He was not yet holding a trumpet for the sun-centered view, but interest was growing in his mind. He also studied how bodies resist motion. His thoughts on inertia were forming. He suggested that without resistance, a body once set in motion would keep moving. This was different from the old belief that a continuous push was needed to keep motion going. These seeds would also grow later in the work of others who formed the laws of motion. Telescope and the sky. In 1609, news reached Galileo of a new device made in the northern lands. It used lenses to make far objects look near. At once Galileo saw its promise. He did not have the exact design, so he experimented rapidly. He shaped and tested lenses, held them at different distances, and improved the power. Soon he built a telescope that could magnify objects many times. At first the device had value for ships and war. A lookout could see sails far earlier. Galileo showed it to leaders in Venice. They were pleased, and this helped his standing and salary. But Galileo's deepest interest was not ships, it was the sky. He pointed his instrument at the moon. Instead of a perfect smooth disk, he saw rough dark and light areas. He realized these were shadows of mountains and holes we call craters. The moon was a world with heights and depths. This hit the old idea of perfect heavenly spheres. He turned the telescope to the Milky Way, a faint white river of light across the night. Through the lens it broke into countless small stars. The heavens were richer and more crowded than the eye alone could tell. On clear nights, he studied the bright planet Jupiter. He saw small points of light near it. Night after night he came back. The points changed position. They did not wander off but stayed near Jupiter, shifting sides. He realized they were small moons going around Jupiter. This was a clear example of bodies orbiting something other than Earth. It showed that not everything circled our world. He published these findings in a small book called The Starry Messenger in 1610. The book was short but powerful. It spread fast across Europe. Some praised him. Some doubted or even refused to look through the glass. He also observed dark spots moving across the sun's bright face. These sunspots changed shape and position over days. To protect his eyes, he watched them in a safer way by projecting the image. The spots showed that the sun itself changed. This again broke the idea of perfect, unchanging heavens. He also found that Venus showed phases like the moon. This fit well with a model where Venus moved around the sun and sometimes showed a full or crescent face to Earth. These findings made Galileo famous. He gained a position as chief mathematician and philosopher to the Grand Duke of Tuscany. Honor and pressure came together. With fame came critics. Some said the telescope tricked the eye. Some said the shapes were illusions. Galileo urged them to look through the lens. Some refused, because the results threatened their system of thought. Galileo's style in writing was lively. He explained what he saw in simple yet strong words. He brought readers to the eyepiece. He reflected on what the new sights meant. The telescope became more than a tool. It became a symbol of a new method. Extend the senses, record, share, test, and build a common view of nature. Conflict and trial. As Galileo's support for the sun-centered system grew stronger, so did opposition. He believed the new observations gave weight to the idea that Earth moved. Moons around Jupiter showed that not every object circled Earth. Phases of Venus fit the sun-centered model better than the old Earth-centered one. Still, many scholars and church figures held to tradition. Some feared that change in the picture of the heavens would lead to doubt in other areas of belief. Galileo wrote letters explaining how certain parts of Scripture could be read in a way that allowed for Earth's motion. He argued that the book of nature was written in the language of mathematics, and that careful study of nature did not oppose true faith. These ideas were sensitive. He had friends inside the church who advised caution. For a time he slowed public support, but his mind kept working. In 1632, he published a book in the form of a dialogue. It had 3 characters who discussed the 2 main world systems, the old Earth-centered one and the newer sun-centered one. The writing was clever. One character who held the old view sometimes appeared weaker. Some readers thought this figure's words echoed views of an important leader. This did not help Galileo's case. Soon after, he was called to Rome to face inquiry. He was questioned about his support for Earth's motion. The trial was stressful and heavy for an older man with health problems. In the end, he was found guilty of strong suspicion, of holding an idea that was against the teaching of the church at that time. He was told to deny that he held that the earth moves. He agreed to follow the order. He was not burned or put in a dark prison. Instead, he was kept under watch, first in places of supporters, then in his own home near Florence. This is called house arrest. Still, it limited his freedom. He could not travel or publish freely on the motion of Earth. Stories later claimed that after his formal words of denial, he whispered, "And yet it moves." There is no strong proof that he said this at the time. but the phrase became a symbol of how truth can live even under pressure. The trial has since been studied as an example of conflict between new scientific methods and old authority structures. Yet the history is more complex. There were politics, personality issues, and timing. Galileo's sharp style in argument may have deepened the crisis. Still, his method survived. Others continued to build a new physics and astronomy. Later years and legacy. In his later years under house arrest, Galileo did not stop working. He turned his mind to motion again. He wrote a book on the strength of materials and the science of motion, called Discourses and Mathematical Demonstrations, relating to two new sciences. Because of limits in Italy, the book was printed in the Netherlands in 1638. It became a key text. In it, he gathered decades of thought on falling bodies, projectiles, and the behavior of beams. He used dialogues again, but with a tone shaped by age and experience. His health declined. He suffered from problems with his eyes and later became blind. Yet his inner vision stayed active. Students and young scientists visited him. One of them was a young man named Evangelista Torricelli, who later invented the barometer. Galileo's home became a quiet center of thought. He dictated ideas. He reviewed notes. He worked to make his past work clear for the future. His daughter-sister Maria Celeste had been a comfort through letters, but she died before him, a sad loss that touched him deeply. Galileo died in 1642. In the same year in England, Isaac Newton was born. Many later writers like to point out this passing of a torch across countries. Galileo's careful experiments and clear reasoning helped set the stage for Newton's laws of motion and universal gravitation. Galileo did not give all the answers, but he gave a way to ask and test questions that led to powerful answers. His legacy is not just in physics or astronomy. It is in the attitude that nature can be read like a book if we use careful observation, measurement, and math. He showed that authority by itself is not enough. A claim needs evidence that others can repeat. He showed that tools can extend the senses and reveal hidden facts. He showed the value of sharing methods so others can check them. These ideas are now part of what we call the scientific method. Today, when we send probes to other planets, map the surface of Mars, or search for life in distant worlds, we stand on a path that Galileo helped clear. When a student times a swinging weight or rolls a ball down a smooth track in a school lab, they are tracing lines first drawn by his mind and hands. He reminds us that deep change can start with simple acts. Watching a lamp, drawing a shape, grinding a lens, recording a time. Galileo's life also warns us about pride and conflict. Clear ideas can still meet resistance. Change can be slow. Dialogue matters. Even a brilliant mind must work within a human community. Yet over time, good methods and true results tend to spread. False ideas fade when they cannot stand repeated tests. This offers hope for all who search honestly. Galileo Galilei's name, now stands for curiosity joined with courage. His story tells us that asking, testing, and sharing can reshape how the world thinks. His life lights a path for learners everywhere. Conclusion: Galileo's journey from a curious boy in Pisa to a careful observer of the heavens changed how people think about knowledge itself. He showed that truth about nature does not rest only in old books or in the words of important men. It rests in patterns that can be seen, measured, and shared. He shaped a new spirit. Trust careful observation, use math as a clear language, build tools to see farther, test ideas again, and invite others to do the same. This spirit lives in every modern lab, classroom, and mission control room. His courage also speaks across centuries. He stood firm when critics laughed at the telescope. He wrote with energy when some warned him to be quiet. He accepted limits late in life, yet still shaped ideas that would support future giants. His errors and sharp edges do not hide his gifts. They make him human. They show that progress is the work of real people with hopes, worries, and flaws. The impact of his work reaches into daily life. The timing of pendulums helped clocks improve. The study of motion helped engineers design safe bridges and strong machines. The method of evidence helped doctors test treatments. The view of Earth as one planet among many helped people think with more humility and wonder. Remember Galileo when you look at the night sky, or when you watch a dropped object fall. Behind these simple acts stands a long line of thought he helped begin. If you enjoyed this clear and inspiring life story in simple English, subscribe now to this channel. More graded reader-style stories are coming to help you grow step by step. Keep listening, keep learning, and keep your sense of wonder alive.